Yo, 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 don't you know it's time to go over these
Yo, yo.
solving system class.
Yo.
Okay, number one, Chewy, zip it. Number one, we are trying to, right? Okay, number one, we are,
Let's get started.
in solving system equations, when we're asked to graph, we need to graph both lines, we need to graph both correctly, we need to use a ruler, and the point of intersection will be the solution. What is the y-intercept here?
1.
What is the slope?
1 over 1.
1 over 1, good. Or it could be negative 1 over negative 1. So I can rise 1, run 1.
Yep.
I'm going to graph that line.
Graph it.
Okay?
Oh my gosh.
So,
Stop. Mr. Hildo.
okay, you guys are going to interrupt me. It's just going to take much longer. Okay, the second line, we are going to start at negative 5. And we're going to, the slope is 4 over 1, so it's either 4 over 1 positive or negative 4 over negative 1. So I can rise 4, run 1, rise 4, run 1, and I see that they share a point, and I can find them, but I have enough, right, Carson, that I can just go and put it down there, and I'm going to fix it. Okay? It needs to be right, and you need to use a ruler, you need to show the point of intersection, and then you need to write the answer correctly. If you did all that work and you mixed up 3, 2, I'd take half off. So make sure you name that point correctly. 2, 3. Number 2, same dealio. Y-intercept is negative 1 for this one. So let's start with that one. We're going to rise 3, run 2, rise 3, run 2. That's my first line. Oop, there it is. Okay, we'll find out. The second one is negative 1. Oh, you're right. Lizzie is right. We're going to rise 1, run 1. You still need to graph both lines correctly. I'm still evaluating that as well. Obviously, that's a very important skill, as we just saw in that IAV. So, what is the solution? 0, negative 1. Okay? All right, moving on. Any questions so far? Great. Number 3. Now we're going to substitute. Okay? Substitute means I'm going to take what, first off, I need to solve for a variable. It's already done for me. Look at that now. Step 2. I'm going to replace or substitute what y equals down here for y up there. So I'm just going to rewrite it like this, and I'm going to put in what y equals for y up there. Everything else is the same as the first equation. Step 2. Step 2, I'm going to distribute. Go ahead. Whatever. Turn off the one you need to turn on. Okay? So I distributed. Now I need to get x on one side, numbers on the other. So this is what we spent a lot of time on earlier this year. Okay? We are going to add 3x to both sides. So I get 27 equals, that's 2.5 or 2.5x plus 2. Since it's a terminating decimal, it is appropriate to go ahead and make it a decimal. Okay? And then we're going to go ahead and subtract 2. And we get 25 equals 2.5x. Divide both sides by 2.5, and x is 10. So x equals 10. Okay, if x is 10, I'm just going to plug into the easier equation. I think that one's way easier, right, Bridget? Y equals negative 10 plus 9. The reason I put the 10 in parentheses is that's what I'm putting in for x. Negative 10 is negative 10. Plus 9, which is negative 1. Y is negative 1. What is my answer? 10, negative 1. If good news is, you can go back to this video, do your own pace tonight, and pause it, write it down, however you want. Brian, educate, extra extension. You would add one now. Then you'd have negative 2.5 over here and negative 25 over here, and you still get 10 if you get all the calculations right. Number 4, solve by graphing. Okay, we have to get y alone in the top, right?
This is the one I'm.
Okay, well, let's see what we do. So if we look at the first one, y minus 6x equals 4, we are going to add 6x to both sides, and we get y equals 6x plus 4. So we can graph that. Or, now, to start at 4, this is 6 over 1, so that's positive 6 over positive 1, or negative 6 over negative 1, which is what we're going to need to use here, because we need to go down 6, left 1, because if we go up 6 over 1, it goes off the graph. So that's where it's beneficial to understand you can go both ways. Nope. Negative 6, negative 1, or positive 6, positive 1. I think some of you had it wrong when you added this one. Okay? So, let's take a look at the second equation. 2y minus 12x equals 8. Okay? We need to get y alone, right? Add 12x. 2y equals 8 plus 12x. Divide both sides by 2, and what do we get? We get y equals 4 plus 6x. Or 6x plus 4. What does that mean? It means it's the same line, and it would be over the top, so it is infinite solutions. Because they intersect everywhere. It's the exact same line. It was just in disguise. Okay? So you need to graph the line correct. If you graph the line wrong, then you got infinite and like that. You go back to the top. It's just recording everything on the software itself. Yeah. Just like when you watch a Khan Academy video, you see something writing on the screen. It's just that. Okay, next page. Now, some of you have forgotten, and this is in your toolkit, I know it because we've graphed it on several occasions. X equals negative 3 is a vertical line. What's the only thing we know about x equals negative 3? X is always negative 3. What does that look like? Yeah. Right, Brian? The only thing that's true on this one is x is negative 3. Negative 3, 1, negative 3, 2, negative 3, 3, and so on. Yeah. Okay, now let's graph the second line. Start at 2, and we're going to, this is negative 2 over positive 3, or positive 2 over negative 3. So we can either go positive 2, negative 3. Oh, looks like I don't need to go any further. Okay, I can just go ahead and graph that line and show that the point of intersection is negative 3, 4. Some of you missed this because you graphed x equals negative 3. I'm like, really good luck. Okay, you're going to have to give me more specific questions. Oh, a lot of your work I looked at was good.
I have no idea.
That's not true. But you know how to identify the line or cat. You know how to identify the slope. Good thing. What do you do with the plus 2? That's my starting point, right? Remember y equals mx plus b? Okay, and this goes back to what we worked on a couple months ago. Whoops, did that wrong. Y-intercept. But the good news is you can go home and spend some time and watch the video and slow it down and pause it. You can go look at all the examples we've been working out. So you have a lot of resources at your fingertips. Number 6. This one was meant to be pretty simple. What does y equal? Negative x. So I'm going to replace y up above with negative x. 4x plus 5 times, what's y?
No, 1.
Negative x equals 7. And everybody see what I did? I replaced y in the top equation with what y was equal to the bottom equation because step 1 was done for us. Now look. Simplify. What's 5 times negative x? Negative 5x. Simplify some more. That's 4x plus negative 5x. Negative 1x. Okay? How do I solve that? Divide by negative 1. Good. So x equals negative 7. Okay. X is negative 7. So I'm going to plug that into one of those equations. I think it's easy to go into this one. Y equals negative x. What's that? Negative 7. What happens when I have a negative negative? Yeah. Okay? Now, don't forget you can check every single one of these. What's 4 times negative 7? Negative 28 plus 5 times 7? 35. What is negative 28 plus 35? 7. Is that what it's supposed to be? Yes. Let's check the second one. Does 7 equal a negative 7? Yes. So check. It works in both. Okay. Next. 7. Y equals 2x. Okay. So I'm going to substitute 2x in for y up above. 3x plus 5 times 2x equals 26. Can we understand the substitution part of that one? Hey, you have to help me understand what you don't understand. Yeah, that doesn't help me. You say everything I can. I can't go back and tell you. Okay, well then, I'm going to have to walk you through this. You've done this since day 4, today for this. So you should be able to verbalize right now what it is you don't understand. Okay, what you don't understand the last time. Okay, that doesn't help. We're not going to go anywhere if you say it. That doesn't help right now. Yes, Nathan. It's going in for y. So the y is gone, and what's there? What y equals here? 2x. So I replace it. Okay? 3x plus 10x equals 26. So, simplify. 13x equals 26. Oh, what do we do? Divide by 13. Right? X is 2. Good. It's not so hard. If X is 2, what's y? 2 times 2. Good. That's a mistake. Try to plug it back in. Right? Find y. Okay?
Hey, I got that one right. Go out.
Okay, next one. X is solved for, so that step's done for us. Really, it didn't. I told you we'd make this pretty simple for you. Probably get to spend a lot of time getting extra y alone. It's already done for you. You just have to substitute, simplify, and solve. So I'm going to put in substitute y minus 1 for x in the top equation for x. So Nathan, instead of x, I'm going to write when x is equal down here, right? Check it out for the last question. Okay. So then I get 4y minus 4 plus 9y equals 22. I have to continue to simplify by adding like terms. I need to get y alone by adding 4. 13y equals 26. Y is 2. Okay, y is 2. Alright. Okay, so y is 2. What's x? Let's find out. Sorry, you have to erase this so you can watch another video. So, if y is 2, then I know that x equals y, or 2 minus 1. I hope you can all do that. What's the answer? 1.
Oh my God.
Is 8 plus 9, if I put in 1 for, if I put in 1 for x, I get 4. 2 for y, I get 18. Is 4 plus 18, 22? Yes. Is 1 equal to 2 minus 1? Yes. I know it works. Okay. Number 9. When solving the system equations, how many different solutions are there? 3. 1. None. Infinite. One solution can be in the form of an ordered pair. Okay? If the solution is no solution, the slopes are equal or the same. I would accept either answer. And the y-intercepts are different. Right? Because they never intersect. Well, parallel, but they would never intersect because they have different y-intercepts. When the solution is infinite, the slopes are equal and the y-intercepts are equal. Yeah, just like that problem we had in the test. When graphing systems of equations is solved, the solution is found at the point of intersection. Okay? I'll probably ask some questions similar to that, but not exactly that, obviously. Question, Cameron? Well, not to say equally apart. I just say if you have another way of saying they're not the same, you say not the same. No, I would have given you partial credit based on the way you got. Right? Partial means part. Partial. Check this out. Partial. Look at the root. We'll lay a dart for you.